Fraction Busters. Fraction Busters is a useful way to learn because it's really going to work with all types of problems. Once our problems get harder and we have more than just the x tiles on one side and the unit tiles on the other, if I have fractions in there, this method won't work. Fraction Buster is, I always like to think of it as a Ghostbuster. A Ghostbuster wants to go around and get rid of all the ghosts. So we want to get rid of all of our fractions. So our equation is still the same thing. It's equivalent to each other, but it just has numbers that are much easier to work with. So in the Fraction Buster, I'm looking at all the denominators, and I see a 5 here. And I know some of you are thinking, well, 60 is really 60 over 1. So technically, I have a 1 right here, but it doesn't really matter. What I want to do is look at the denominators, the bottom numbers of my fractions, and figure out what number they both will divide into. And so I know both of these numbers will divide evenly into 5. So I am going to multiply everything by 5. Now, 3/5 x is really working together, so I'm not multiplying the 3/5 by 5 and the x by 5. I am just multiplying 3/5 x by 5. Sometimes people like to put it 5 over 1, just so that they can remember that you're only multiplying the numerator by 5, not the denominator. I'm not multiplying by 5 over 5. I'm multiplying by the whole number 5. So 5 times 3/5 would be 15 over 5x equals, and this is where we have to be careful. I must also distribute that 5 to my number on the other side of the equal sign. So 60 times 5 is 300. Now I haven't busted out of the fraction yet. I haven't gotten rid of the fraction. I just made a bigger fraction. But really, if you look at this new fraction of 15 over 5, I can get rid of the fraction now because 15 over 5 is the whole number 3x equals 300. Now, some people like this method because now you're used to whole numbers that you're used to solving. I have 3 x's on one side. I have 300 unit tiles on the other. So my last move is to split. I want to find out what 1x equals. And if 3 x's equal 300, then 1x equals 100. And I'm done. Now, with the fractions on both sides, it's a little bit more challenging. You just have one extra step. I have the denominator 5. I also have a denominator of 7. So now I'm not going to multiply my whole fraction by 5 or 7. I have to think of what number will 5 and 7 both divide into. It helps if I use the lowest common multiple, but if I don't, it will still work. And in this case, it is 35. So I'm going to multiply both numbers by 35. So remember, if I want to, this is 35 over 1. I'm only multiplying the numerators by 35. So I know 35 times 2 is 70 over 5. These equal, now don't forget, I have to multiply both numbers by 35. So I'm also doing 35 times 3, which is 105 over 7. I still have fractions, but these fractions are better than the original fractions because these fractions can be turned into a whole number. You may want to have a calculator because I'm going to do 70 divided by 5 to figure out how many V's I have. So 70 over 5 is equivalent to 14 V's. And then I'm going to do 105 divided by 7, which equals 15. So I have now busted out my fractions. This fraction, 14V equals 15, is equivalent to my original fraction, but look at them. This bottom one is a fraction that's not that difficult to solve. I have my V's, my X tiles on one side, and my unit tiles on the other, so the last move to do is split. I want to figure out what 1V equals. So 14 divided by 14 would leave me with 1V equals 15 over 14. Now, I can't leave my fraction as a fraction greater than 1 with my numerator larger than my denominator, so 14 will go into 15 one whole time with a remainder of 1/14. So V equals 1 and 1/14.